Hey everyone, welcome back. Ready for another deep dive?
Let's do it.
Awesome. So today we're tackling a pretty hot topic, quantum computing. Specifically,
A breakthrough in quantum error correction.
you got it. And what's making this deep dive extra exciting is that we're looking at a piece straight from breaking the quantum code.
Pasted text, right.
Exactly.
Yeah.
And get this, it's hot off the press. So you know what that means.
We're getting cutting edge insights.
Exactly. Front row seats to the quantum revolution, my friend. But before we jump into all the mind-blowing stuff, I think it's good to set the stage, you know.
Agreed. Lay the groundwork.
Okay, so for anyone who's maybe new to this whole quantum thing, why is quantum computing such a big deal? What's all the hype about?
Oh man, where do I even begin?
Ha, I know, right?
It's like, traditional computers, the ones we use every day, work with bits.
Right. Zeros and ones.
Yeah, exactly. Like a light switch, it's either on or off. But quantum computers, they use qubits. And a qubit, it can be 0, 1, or both at the same time.
Whoa. Hold on. Both at the same time.
Yeah, think of it like a dimmer switch, It's not
Right.
just on or off, it can be anywhere in between. That's superposition. And that's what makes them so powerful. They can tackle problems that would take classical computers, even the super powerful ones, millions of years.
Okay, that is seriously mind-blowing stuff. But so we've got these qubits that can be in multiple states at once, which is amazing, but it's also where things get tricky, right? Because I always hear about how fragile these qubits are.
Oh, absolutely. That's the catch, right? They're incredibly sensitive. Like, even the tiniest disturbance can mess them up. A stray photon, a temperature fluctuation, anything.
Yikes. So it's like trying to do super complex calculations on a computer that's constantly glitching.
Yeah, and that's where quantum error correction comes in. It's the key to making quantum computing actually work. And the breakthrough we're talking about today, this AlphaQubit, it's a huge step in the right direction.
So tell us more about this AlphaQubit. How does this thing work? What makes it so special?
Well, it's a collaboration between Google's DeepMind and quantum AI teams. And what they've done is created this AI-powered decoder that can spot and correct errors in qubits, but get this, without messing with their quantum state.
Hold on. I thought interacting with the qubits was kind of the whole problem in the first place.
It was. But AlphaQubit, it's like it's monitoring the whole system from a distance, analyzing the overall behavior, and using some fancy machine learning algorithms, it can figure out where the errors are and how to fix them without directly touching those delicate qubits.
Okay, so it's like if the qubits are a bunch of spinning plates, instead of trying to steady each one individually and risking knocking them over, AlphaQubit is more like adjusting the table they're spinning on.
Exactly. And you know what's really cool?
Right.
The results are pretty impressive. AlphaQubit can detect and correct a wide range of errors, and its accuracy, way better than anything we've had before.
Okay, so now I'm really starting to see why this is such a big deal. But let's zoom out a bit. What does this breakthrough actually mean for the future of quantum computing?
Well, it's a huge step towards fault-tolerant quantum computing.
Fault tolerant. What's that?
Basically, it means that the errors are handled so well that they don't mess up the whole computation. And, this also shows us how powerful collaboration can be.
Right, combining AI and quantum physics. Like two superpowers teaming up.
Yeah, exactly. But, and this is important, we're still early in the game.
You're saying we shouldn't expect quantum computers on our desks anytime soon.
Not quite yet. Scaling up this tech to work with thousands, maybe even millions of qubits, that's still a massive challenge.
And I imagine AlphaQubit, as amazing as it sounds, probably isn't a perfect solution, right?
You're right. There are certain types of errors it still struggles with. So understanding those limitations is going to be really important for the future of this technology.
So for our listeners who are following all this quantum excitement, what should they be paying attention to as things evolve?
I'd say keep an eye on how this AlphaQubit approach develops. Can it tackle those trickier errors? How well will it integrate with different types of quantum computers? And look out for other creative solutions to error correction that are bound to pop up.
Because this is a field that's just bursting with potential. All right, so as we wrap up our deep dive here, I'm left with a final question for you all to think about. Now that error correction is looking so promising, what other big breakthroughs do we need to see to make large-scale, practical quantum computing a reality? Keep that question in mind as you keep exploring this amazing field. It's going to be a wild ride.
It sure is.